Good Jesse. Hello guys, hello December, hello. Anyone need any help about anything? Anyone who needs help with anything specific? Yeah? Ooh, hello. Anyone need help with anything, guys? Anyone who's anyone? Anyone need help? Anything? We're all about maths here, guys. We're all about maths. Maths, nothing else. Pelkeka now, which part? Functions, please. What grade functions? What grade? If you're saying functions, please, what grade? Grade 12 functions. You do realize that grade 12 functions and grade 11 functions, let's come here, let's just check something out. Just want to see if we understand this much. Pearl. So Pearl, first and foremost, hopefully we are together here. A straight line function has an equation y is equal to mx plus c. All right. This is the standard form of a straight line function. The m in the equation stands for gradient. Okay. And the gradient is basically the measure of how steep a line is. All right. So m stands for gradient. It is synonymous with the word slope. All right. And then the c here stands for what we call the y-intercept, where the graph cuts the y-axis. So we have a very important equation. The standard form of the equation of a straight line is y is equal to mx plus c, where m is the gradient, where c is the y-intercept, where the graph cuts the y-axis. All right. Now a little bit more about the m here. The m, whenever m is less than 0, that means our graph is a decreasing one. Okay. In other words, it slopes downwards like this. That's the direction of our line. If m is less than 0, that's the gradient. If m is greater than 0, then the graph is increasing. In other words, it is increasing like that. You can expect a straight line that is like this. Okay. I hope you understand that. Okay. So I repeat, y is equal to mx plus c is the standard form of the equation of a straight line. The m, whenever the equation is in standard form like this, then the m is the gradient, c is the y-intercept. By y-intercept we mean where the line cuts the y-axis. I'm sure you know the Cartesian plane. Cartesian plane has the y-axis and it has the x-axis. So where the graph or the straight line cuts that, we call that the y-intercept. Okay. When m is less than 0, the graph is decreasing. When m is greater than 0, the graph is increasing. All right. I also want to add that when m is equal to 0, we have a horizontal line. Okay, where our y value is constant. Okay, and also when m is undefined, we have a vertical line. All right, So these are the state or condition that our value m, the gradient, can be in. Either m is less than 0 in standard form, decreasing straight line. M is greater than 0, increasing straight line. M is equal to 0, have a horizontal line. When m is undefined, okay, we have a vertical line. And what's interesting is that this standard form will apply to when m is greater than 0, when m is less than 0, and when m is greater than 0, and also when m is equal to 0. You are bound to have a standard form of your equation in this form. Of course, when number 3, m is equal to 0, that means 0 times x, that will be eliminated and you'll only have y is equal to c. That's why for a horizontal line, our equation is y is equal to c because m is 0. So 0 times x leads to the elimination of the horizontal line. Our y value is constant for a horizontal line. So the form, this standard form, applies to when m is less than 0, when m is greater than 0, and when m is equal to 0. When m is undefined, the form becomes x is equal to a constant, because for any vertical line, the graph will cut the x-axis, not the y-axis. It will only be in conjunction with the y-axis if x is equal to 0. But if x is equal to c, okay, that's when basically you will have a vertical line like that. Okay. All right, so I hope that makes sense now. So for 1, 2, 3, the standard form of the equation will apply. But for when gradient is undefined and it's a vertical line, then our equation is going to be x is equal to some constant, because for any vertical line, it is the x value that is the same throughout that vertical line. Okay. All right, then here's something else to know about a straight line. The domain. What is domain? Remember, domain speaks to the possible x values where the function exists. I repeat, domain means the possible x values where the function exists. Okay, so for any straight line, we say that the domain, what do we mean by domain? We mean the x values where the function exists from left to right. So for a decreasing straight line, your function will exist from left to right. So when we want to state the domain for a function that is decreasing, that basically has no restriction but is infinite in nature, we say that the domain of that function is x is an element of real numbers. What does that mean? It means that the function exists everywhere from left to right. Okay, so when we say x is an element of real numbers, we mean that the function exists everywhere from left to right. From left meaning from your most negative x value, to right meaning to your most positive x value. So we can also write that domain. This thing of x is an element of R can also be written as x is an element of negative infinity to positive infinity. We can also write the domain this way. This here means the same thing as that there. So if you want to write x as an element of R, go ahead. If you don't want to write it this way, you can always say x is an element. You use open brackets, you say negative infinity to positive infinity. Okay, so Pearl, I hope you are with me so far, that when we speak about domain, we are speaking about the possible x values where the function exists from left to right. When you're talking about domain, you are talking about x values where the function exists from left to right. Why are we saying from left to right? Because when we are talking from left to right, we're talking about the values of x from left to right. And from the left, you have your most negative values. To right, you have your most positive values. Hence, we say x is an element of real numbers. So that would apply for when the gradient is less than 0 from left to right, x is an element of real numbers. That would apply for when the gradient is greater than 0, because from left to right, once again, if the graph is infinite, it means x is an element of real numbers. That would also apply for when the gradient is equal to 0. We would say x is an element of real numbers. But let's be very careful. When the function is a vertical straight line, then the domain will only be x is equal to whatever the x value is for that particular vertical line. So there's always a bit of a difference when we are dealing with a straight line that is having a gradient that is undefined, meaning a vertical line. So for instance, if this straight line, which is vertical, has the equation x is equal to 2, that means the domain for that function, this function only exists. If we're going to talk about the domain, we're going to say x is equal to 2, because the function only exists on the vertical line x is equal to 2. That would be the domain. Okay, I hope we are together there. So that's why we need to have this distinct differentiation between when m is less than 0, m is greater than 0, m is equal to 0, because we can see that from left to right, from left to right, from left to right, if the functions are infinite, then x is an element of R will apply for 1, 2, 3. But when the gradient is undefined for a vertical line, the domain is x is equal to whatever the equation of that vertical straight line is, because the function only exists on that particular x value and nowhere else. So we can't say x is an element of R for a vertical line. Okay, I hope that is very clear. Now I'm going to move from domain, because remember, what did I say domain is? Domain is the possible x values where the function exists. Let's move on to range. What is range? Range is the possible, not x, but y values where the function exists. I repeat, range is the possible y values where the function will exist. Okay, so let's go and look at where m is less than 0. So if we have a vertical straight line that is decreasing in nature, and that is decreasing in nature like this, that means we're looking at range. We're looking from left to the right, but we are looking from the bottom to the top, because remember, the y-axis is from the bottom, the smallest y value, to the top, your biggest y value. From the bottom to the top. Started from the bottom, now we hear, you know that song, started from the bottom, now we hear y value, the range. We always write the range from the bottom to the top. So if we are looking at a gradient that is less than 0 for a decreasing straight line, from the bottom to the top was an element of real numbers. What does that mean? It simply means that y, guys, we can also say, if we are writing y is an element of R, remember we can also write this in the following way: y is an element minus infinity to positive infinity, and we can use open brackets. Are we together? Okay, so yeah, please guys, especially Kekana, if you want to request to be a guest and you want to chat about this, and maybe you want to ask questions directly and I'm losing you at certain places, please, you are more than welcome to request, and we can obviously ask those questions that you want to ask directly, instead of like asking the questions in the comment section. If you want, that's up to you. Okay, so that is a range, guys. So for a decreasing straight line, y is an element of real numbers. As long as the function is unrestricted from the bottom to the top, y is an element of R. For an increasing straight line, y is an element of R from the bottom to the top. That's where the function exists. For a gradient that is equal to 0, a horizontal straight line, can we say y is an element of real numbers? No. We can only say y is equal to whatever the y value of the function is, because remember, from the bottom to the top, where does the function exist? It only exists at that y value. Okay, so we're going to have to say then that y is equal to whatever the equation of the function is. That would be the range of the function. It does not exist above, it does not exist below that line, it only exists on that line for a horizontal straight line. So we wouldn't say y is an element of R, we'd say y is equal to whatever that value of the horizontal line is. Then, last but not least, what about a vertical line? Yes, for a vertical line, if we say y is an element of real numbers, as long as the vertical line is unrestricted, we would say y is an element of R applies for this vertical line, because from the bottom to the top, the function truly does what? Exist. Okay, so these are things we need to be aware of as we look at how to write the domain and the range of the function. I want to repeat again, when you look at the domain, guys, okay, you must be able to say which possible x values does this function exist in from left to right. Why from the left? Look, from the left is your smallest x value, and to the right you have your biggest x value. Range, we say, is the possible y values where the function exists from the bottom to the top. Why from the bottom? Because from the bottom you have your smallest y values, and to the top you have your biggest y value. So we must always check, where does the function exist? Very, very important that is the case. And what we are now seeing sometimes is that there are sometimes restrictions that are just very interesting. I want to give you an example here. Say we had a function like this. Okay, because now, things are getting very interesting sometimes when we are asked to sketch a function. I'm just going to use an example. Let's say they asked us to sketch the function y is equal to x plus 4. And then they tell you that where x is an element, and then they say the following. Let's say they say minus 8 to 5. And rightfully so. They say square bracket, open bracket. You would understand why they're saying y is equal to x plus 4, where x is an element. Now, there's a restriction that is being put on the straight line. Please take note, guys, that this straight line specifically, all right, is from negative 8 to 5. They have a closed square bracket here, which is basically a representation of this shaded restriction of the line, which means this graph starts from negative 8 all the way to where? To positive 5. But you see, we use an open bracket to indicate that this function does not go beyond this line. It does not go beyond this point of x. It does not go beyond this point of x. But in a corresponding nature, guys, we need to understand that this function as well, okay, if we were to say what is the domain of the function, obviously we know what the domain is. We wouldn't say here that x is an element of real numbers. No, because this function basically does not exist everywhere from left to right. From left to right, this function only exists from negative 8 to 5. And we are restricted in that negative 8 is included, but positive 5 is not included. You would remember this from grade 10. Open dot means the value of x is not included. Shaded dot means the negative 8 is included. All right. Now, if I use this function and try and find the corresponding y values, if I take this negative 8 and substitute it, y is equal to negative 8 plus 4. What's negative 8 plus 4? Y is equal to negative 8 plus 4. That gives us negative 4. That would suggest that the corresponding y value, guys, is actually negative 4. So when x is negative 8, y is negative 4. Let's take 5 and substitute into the function and get the corresponding y value. Let's check this. Y is equal to 5 plus 4. In the place of x here, I'm substituting this 5 there. 5 plus 4 gives me 9. So that means my corresponding y value there is 9. Now, if I was to write down the domain, of course the domain is already there. It's -8 to 5. I say close bracket, obviously, to show that -8 is included. And then I say open bracket to show that the +5 is not included. If I was to write down the range, oh, and by the way, sorry, with this domain, guys, with this domain, when I said x is an element of close brackets, -8 to 5, this -8, like I said, from the left, you remember I said domain is the possible x values where the function exists from left to right. I repeat, the domain is the possible x values where the function exists from left to right. -8 to what? To 5. So the function exists only there. Okay, we didn't say here x is an element of real numbers because we can see the function does not exist beyond these values of x. It exists everywhere in between. At -8 it exists. At +5 it does not quite exist. It is not included there, but it goes up at least before +5. So that's why we have -8 close bracket to 5 open bracket. You see, this is the smallest left to the biggest right. Do you see that? Left to right. Very important. Domain is the possible x values where the function exists from left to right. Range, possible what? Y values where the function exists from the bottom to the top. So when I write the range here, I would say y is an element. Now, this -4 is the corresponding x value for -8, where -8 is included, which means the -4 is also what? Included. So I'm going to say y is an element of square brackets. Why square brackets? Because of the shaded dot. From what? From -4 to where, guys? From the bottom to the top. Started from the bottom, now we here, that's the range. Started from the bottom now to the top, that's the range. Started from the bottom to the top, that's the range. Started from the bottom to the top, that's the range. The y values, the possible y values where the function exists from the bottom to the top, that's the range. Okay, so -4 to where, guys? 9 corresponds with 5. It is open, so that means we use a open bracket to 9 open bracket. That is my range. Okay, that is my range. So that is why I'm saying nowadays, guys, whenever you are asked to sketch a graph, if they ask you to sketch a graph and there's a restriction, please make sure that there are end points. In the Eastern Cape September trial paper for grade 12s, you know, they were asked to sketch a graph. But the graph that they were asked to sketch had what? A restriction. Most learners did not actually write endpoints when they sketched the graph. And as a result, they lost marks. Most learners, when they wrote down the range, did not write down the range the way that they saw the graph being actually sketched, but they wrote down the range in accordance to what is usually put down in the notes. What do they know? Usually they know that the domain for any unrestricted line is x is an element of real numbers. And the range for any unrestricted straight line is y is an element of r. That is normally the case. But in an abnormal case where the function is restricted, these functions are unrestricted, meaning there's no restriction, no end, no beginning. So therefore we say x is an element of r to show that the function is from -infinity to +infinity for domain left to right, or the range from the bottom to the top from -infinity to +infinity. That's why we write y is an element of r. But guys, if there are restrictions, as you see this straight line having restrictions, shaded open dot. Remember, a shaded dot resembles a closed or square bracket. That's what a shaded dot speaks to. But an open dot speaks to an open bracket. Okay, so an open bracket represents a open dot. So we must always take that into consideration. And when we write down our domain and range, we must always write down our domain and range in accordance to what we see is sketched now functioning in accordance to the restriction. Okay. So I hope we are clear about that very, very important point. Can I proceed and move on? How did I get those y-intercepts? Guys, I didn't get y-intercepts here. They're not y-intercepts. Remember, a y-intercept means where the graph cuts the y-axis. An x-intercept is where the graph cuts the x-axis. I don't have a y-intercept here. What I do have is my end points. Remember, I said y is equal to x plus 4. I want to sketch a function that is y is equal to x plus 4, where x is an element of square brackets, negative 8, to what? To positive 5 open brackets. How would I represent a sketch like this on a Cartesian plane? And all I simply said is that, guys, you can't just sketch this function without acknowledging the restriction that is there. This function we are told to sketch from negative 8 to where? To positive 5. These are the possible x values, your domain. So it must then be clear to us that if we have square bracket, it means we have a shaded dot. The end point for your most negative number must be negative 8, and it must be represented with a shaded dot, because a shaded dot represents a square bracket. Then to where? To 5. So that means where the function ends at 5, it must be an open dot, because an open bracket means an open dot. So when you sketch your function, it must be restricted. When you indicate your domain, you must write your domain as restricted. X is an element of square brackets from negative 8 to 5. When you write your corresponding range, meaning range, possible y values where your function exists, y must be an element of what? From the bottom to the top, as I said with the range, negative 4 square brackets, y square brackets, because shaded dot means what? Square bracket. From negative 4 to what? To positive 9. From negative 4 to what? To positive 9. So these are important points, guys, that we need to ensure that we have covered whenever we are dealing with situations that have to do with domain and range. So that is just something I was going through, because why? I'm still just covering the basics on what the equation of a straight line, what concepts are covered in a straight line. The standard form of the equation, what m and c mean. All right, what do we see when m is less than 0? The decreasing straight line. M is greater than 0, the increasing straight line. M is equal to 0, a horizontal straight line. M is undefined, a vertical straight line. Then I spoke about what domain and range mean. All right, and typically when our function is unrestricted, we say x is an element of real numbers for our what? For our domain, when the function is unrestricted, as you can see in situation 1, 2, and 3. But in situation 4, when the gradient is undefined with a vertical line, our domain will be equal to the equation of the straight line. Because for a vertical straight line, we know that x is equal to some constant value. For instance, x is equal to 2 would be an example of a vertical line. And if we were to write down the domain for x is equal to 2, we'd say the domain is x is equal to 2, because the function only exists at 2, okay, as a vertical line. Then again, when we spoke about range, we said that if the line is unrestricted, then obviously the range, the possible y values where the function exists from the bottom to the top, that means y is an element of what? Of real numbers. If the function is unrestricted and it is a straight line that is decreasing. If it's unrestricted and it's a increasing straight line, we say y is an element of R as well. But if it's a horizontal line, let's be very careful. Our range, guys, will actually be the equation of the straight line, because the range, that means the function will only exist at that y value that is constant for any horizontal line. Okay, but then if the line is a vertical line, our range from the bottom to the top will exist where y is an element of real numbers, so that would apply. Okay, and then as I just now explained, be very careful if there are restrictions. This is not an unrestricted straight line. It is a restricted straight line. It is from negative 8 to positive 5, and from negative 8 it is included, shaded, and then to 5 it is not included, unshaded, open. So therefore, when you write the domain from left to right, the function exists where x is an element of -8 square bracket to +5 open bracket. Shaded dot means square bracket. Open dot means open bracket. So that's how we write the domain. Our range, on the other hand, from the possible y values from the bottom to the top. So we look at this function which does exist from the bottom to the top. It's from -4 shaded. So that means -4 square bracket to what? To +9, your highest number. +9 open bracket corresponds with the open dot. So that would be our range. It is not y is an element of R because we have a restriction. So we say y is an element of -4 to +9. And we use the shaded square bracket, open dot, open bracket to basically indicate that interval. Very, very important. Okay, so this is interval notation, but I do know some people prefer to write it in what you might call inequality form. Some people, they say -8 like this to 5. This is also fine, guys. This and this mean the same thing. This and that mean the same thing. You see the x is there to indicate domain. So to write your domain this way, that's interval notation. To write your domain this way is inequality form. That's also 100% the same thing as that. Do you see that it is x is greater than or equal to -8 but less than 5, which is 100% correct as this. If you write the range, all right, if you want to write in inequality form, remember the range means y, so that means you can say y and then you say greater than or equal to what? -4 but less than 9. Okay, do you see? So the minute I say open dot, it means I do not include, I don't write an equal sign, okay, because it's an open bracket. An open bracket resembles a inequality sign without an equal sign. But then if it's a shaded dot and it's a closed bracket, then I must include the equal sign. Do you see that, guys? Okay. Yeah. This thing must come in. Yeah, the inequality form gives me a problem, so I'll stick to interval. Pearl Kekana, go ahead, please do. Especially now at this stage, you know, now at this time of life, you must make sure that if one thing works for you, you stick to it and you roll with it until, so that you don't miss out on important marks because of carelessness. Then the last thing I want to touch on is how to find the equation of a straight line. Okay, in your formula sheet, you guys have this formula. Okay, very beautiful formula. Y minus y1 is equal to m into x minus x1. Surely we know when to use this form to basically assist us in finding the equation of a straight line. And so surely this should not be too much of a problem for any one of us. Okay, yeah. Okay, all right, are you guys ready for me to move on to the next function? These are just important concepts you need to know about a straight line. Okay, I do understand that when we get to grade 12, what happens is that obviously this is something you learn in grade 10 and in grade 11, but then when you, and also in grade 9, for crying out loud. In grade 9, my grade 9s, for instance, this year, especially this term, we're doing straight lines. And those who were coming into my live session, you may have seen me do a lot of live lessons for the grade 9s as they were preparing to write their tests and the exams. You're probably getting sick and tired of the fact that I'm not doing grade 12 and I'm just always doing grade 9. Okay, so for a straight line function, that form y is equal to mx plus c, very important. Guys, you will know that in grade 12 you do inverse functions, right? And in inverse functions, what is the rule? In an inverse function, if you want to write the equation of the inverse, we would first swap the y and the x. Look at this. In the place of y, I have x. In the place of x, I have y. Then after that, what do? You make y the subject of the formula. You take the c, you transpose it. So now on the other side, you have x minus c. And then you are left with my. What do you do with my? You divide both sides by what? By m, so that you isolate the y. So that's why you see here that the inverse function is y is equal to x over m minus c over m. This would basically be the inverse of our function, it's x over m minus c over m. I hope that makes perfect sense and all of you understand what happened here. Because that's the thing, Moss. Whenever we want to write a standard equation of a straight line function into its inverse, we first swap the letters around x and y. There you can see, in the place of y there's x, in the place of x there's y. Then after that you try and make y the subject. Take the c, transpose it, it's x minus c. That's why you see, for instance here, x minus c. Then the my is left on its own. So you divide both sides by the coefficient of y, which is m. So that means both x and the minus m minus c will be divided by m. And that's why we say that the inverse of the function, the general form, is y is equal to x over m minus c over m. And then obviously we know the notation that we use, functional notation, inverse, f inverse of x is equal to x over m minus c over m. So this is one and the same thing. And if you're talking about domain of that particular function, we are still saying that the domain is the possible x values where the function exists, and the range is the possible y values where the function exists. And we look at that specific function that basically we have available to us, and we check where does it exist domain wise from left to right. The range, where does it exist from the bottom to the top. So basically straight line inverse function, we just need to remember that as grade 10 grade 12 learners. All right, very, very important, how to find the inverse of a function for a straight line. Okay guys, can I move on from straight line functions and go on to parabola? Are we good here? Because I think at least we've covered the concept, right? Just the important concepts that we need to cover when it comes to our straight line functions. These are very important and crucial and critical things. We'll look at questions very shortly, but I just need to check if concept-wise we have our concept in our heads sorted, covered. You know, we are flowing nicely there. Can I move on to the parabola? I just want confirmation in the comment section. I hope there are people that are really genuinely listening to the live and who are feeling like yes, we got you covered, thank you so much. We can move on to parabola. Can I move on to the parabola, the concept for parabola? And then there are questions just waiting for us to be answered. I'm gonna get to that very soon. I just want to check first and foremost that we are together so far. Senandengeto is saying yes. Samkelo Shang is saying yes. Thank you for the content, sir. Yeah, okay, let's go on to parabola. Look at parabola. Kipara, guys. Here in the Eastern Cape, in the place called the Eastern Cape, there are people that usually give people a hard time. They are called Amapara. They usually call them Amapara there in the Eastern Cape, Amapara. They give people a hard time. I don't know if parabolas give people a hard time as well, just like Amapara. Those people that usually they are there on the street, they're always begging for money, they are asking for something. Sometimes when they get sick and tired of being sick and tired of begging, they will harass you and they will take money from you or take things from you. They are smelly there on the streets, they're always dirty, and they are bothersome sometimes. They can really give you a pain, because you'll have someone maybe perpetually always asking for something, that one person, because they know you, Siba, you are nice and all of that stuff. Parabola, bola. Okay, so those are our quadratic functions. Two forms that we need to know. The turning point form, y is equal to a into x plus p, the whole thing squared plus 2. This is called the turning point form of the function. This is what you learned in grade 11, sorry. Y is equal to a. Remember what a stands for? All right, hopefully you understand what a stands for. The x plus p part, all right? Especially if we take that x plus p part and we equate it to 0, If you take that, if you look at this form, y is equal to a into x plus p, the whole thing squared plus 2. We call this the turning point form, the TP form. Why do we call it the TP form? It's because here we can extract the coordinates of the turning point. So if you want to find the coordinates of the turning point, it's simple. If you want the x coordinate, it's just simply taking the expression inside the bracket, you equate it to 0, and you solve for x. So the x coordinate is the inverse of the constant term inside the bracket, the inverse, right? But to be more accurate, you can always take the expression inside the bracket, equate it to 0, and solve for x. You will always get the x coordinate of the turning point. Okay, all right, I hope that's noted. Can we all say amen in the comment section to just indicate that we've noted that to get the x coordinate of the turning point in the turning point form equation of a parabola, y is equal to a into x plus p the whole thing squared plus 2. We take the expression inside the bracket, equate to 0, solve for x, we get the x coordinate of the turning point. Thank you, Hlela. Mbingana, you are the best. Samkelo Shange, Samantha. Oh, Samantha, hello. Good to see you here. I think you lost me there. Pelkekana, one more time. This here is called the turning point form. Hopefully, this is your turning point in your academic performance in mathematics. What do you call it? The turning point. Whew, my goodness, this is so intense for me. Guys, I'm sure you heard about the assassination of Charlie Kirk, the turning point USA. Guys, hey, this is huge for me. I never thought of it this way. Turning Point USA. Yeah, that's what's the name. That's the name of the organization. Wife has taken over, Erika Kirk, now the current CEO of the organization. Turning Point. So hopefully for Pearl, this is the turning point of your understanding and knowledge of parabolas. Y is equal to a into x plus p the whole thing squared plus 2. This is the turning point form of the parabola. Why we call it the turning point? It's because this x plus p part can actually help us to identify the x coordinate of the what? Of the turning point. Okay, that's the first thing. Secondly, this q value here helps us to identify the y coordinate of the turning point. So we just take the q as it is. If this q is positive, we take the q as it is positive. If this q is negative, we take this q as it is negative. So what am I saying? In other words, the turning point for this particular form of the function is negative p and positive q. What do we mean by turning point? You know most, where things turn. All right, this end of the academic year will either lead to this. It's either you are going up, you've been going up since term 1, term 2, term 3, term 4, term 5. What's going to happen now is that as you finish off the year, you are just going to go down. That's one situation that can happen. Okay, negative p and q. Oh, this academic journey of yours may lead to this. You've been going down, and in term 3, you basically even now performed very badly. But what's going to happen now is you are going to rise. You are going to go up. The turning point. You see? So our turning point, we can either have what we call a minimum. Okay? And by the way, the minimum value is the q specifically. Or we can have a what? A maximum. Okay, you need this turning point, this one. Go ahead. It's yours to take. Receive it right now. Put your hand on the screen. Pearl Kekana, put your hand on the screen. As you put your hand on the screen, receive your turning point. Your upward concave up turning point. Receive, Pearl, receive. It is very beautiful. You must receive it. So the minimum value is 2. The maximum, here we talk about the maximum, highest point. It makes sense that we say it's the maximum, the highest that you can reach, the highest point that one can reach here. This is when a, look at this. Now we are bringing in him into the mix. This is when a is what? This is when a is less than 0. It is said, Yeah. You see? Yeah. Sad. Why? Why is it sad? Because it's going to go down. You see that thing? It was going up, now it's going down. That's why we even call this concave down. You see? When you are down and out, concave down, we're gonna go down eventually. No. Yeah, and when something is less than 0, we say it's what? It's negative. You see all of these things. When you are negative, you are feeling down. When you are negative, you're feeling down. You're sad. It's like this is also like a sad face. It's crying. Sad face. Okay, and this one, minimum value. Okay, we have a minimum here. This is when a is greater than 0. In other words, we are positive here. Concave what? Concave up. You see, concave up. So from left to right, what's happening? You are going, but then you go up. You see, you finish off in style. Yeah. Someone said it does not matter how you begin, but how you end. Who's going to care how you did in term 1, term 2, term 3? But all people next year, when your results come out, are going to care about the end of the year result. So you have less than what? 30-something odd, less than 40-something odd days to actually prepare very well and ensure that the end of the year result, what you have sowed, you can reap at the end of the year. So please, guys, that's what matters. Okay. Yeah. Okay, I hope you understand. So this one, when a is greater than 0, it's a smiling face. Concave up, we are positive, right? Yeah, a is greater than 0, we're positive, it's concave up. But we have a minimum. Okay, so our turning point points to the minimum. Our turning point here points to the maximum. And which one is the maximum value or the minimum value? We are always talking about the Q value being the minimum or the maximum for the parabola. So please, guys, I repeat, y is equal to a. What does a tell us? If a is greater than 0, we know that we are happy. We have a minimum, and our minimum value is Q. If a is less than 0, we are sad. Okay, it is negative. We are down, but our minimum value is the Q value. And remember, like I said, this x plus p, okay, the inverse of the p value, or in other words, when x plus p is equated to 0, when we solve for x, the negative p, this here gives us the x coordinate of the turning point, and this Q value that is here gives us the y coordinate of the turning point. Okay, so yeah, there's the turning point, negative p and q, or there's the turning point, negative p and q, depending on whether a is less than 0, that would be the situation. If a is greater than 0, this would be the situation. Okay, yeah. Okay, so I hope that makes sense, guys. I hope that make sense. Kakulu ta da. Okay, any questions here with the turning point form? It's very important, the turning point form, we understand it of the parabola. When we do, it makes a multitude of sense. So I'm just going to go back to the notes here. Even further, it says the axis of symmetry with the equation. What do we mean by axis of symmetry? Hey, remember, this is the x value. Axis of symmetry, vertical line. Makes sense, right? Axis of symmetry, vertical line. X value again here, axis of symmetry, vertical line. You see? Yeah. So if we were to write down the equation of the axis of symmetry, it would be x is equal to negative p. Whatever the x coordinate of the turning point is, that is the equation of the axis of symmetry. Okay? Yeah. What does symmetry mean? It means basically that a symmetrical line that will basically do what? It gives us mirror image of 1/2 of the basic whole. All right, so this side will be the same as that side. It's like this side is a mirror image of this side, if that makes sense. Okay, so we say this is a line of symmetry. It's a vertical line of symmetry. Cuts it into half. Okay, this half and that half, which become mirror images of each other. So that's given by the x coordinate of the turning point. The y coordinate of the turning point gives us the maximum value if it is a concave up function. but the y coordinate of the turning point gives us the maximum value. If it is a is less than 0, it's a concave down function. So I hope we can see, guys, what importance or significance the x coordinate of the turning point has. It gives us the equation of the axis of symmetry, whereas the y coordinate of the turning point gives us the minimum value or the maximum value of the function. Okay, both significant in their own right. X coordinate, axis of symmetry. Y coordinate, minimum value or maximum value of the function. Okay, so whenever they say what is the minimum value of the function, what are they actually saying to you? Find the y coordinate of the turning point and tell us what the minimum value is. Okay, if a is greater than 0, you will be able to tell us the minimum value. If they want the maximum value of the function, then it's a matter of finding the y coordinate of the turning point when a is less than 0 and then telling us what the maximum value is. Simple as that. If they want the equation of the axis of symmetry, then it simply means find the x coordinate of the turning point. All right. So in the turning point form, it's very easy to locate what the x value is, okay, and what the y value is. Because remember, I said the y value is the q value as it is, whereas the x value of the turning point is simply the inverse of the p value. So you can take the expression, equate to 0, solve, there it is. So in this case, x is equal to negative p. So that would be that. Okay. Pearl, I thank you for your thank yous in the comment section. Thank you as well. So there it is, just for emphasis. X of symmetry with the equation, x is equal to negative p. The maximum or the minimum value, remember, as I said, that would be obviously equivalent to whatever the q value is. Okay, yeah. So I'm just gonna write here the q value. That would be the maximum or the minimum value. Q will give us that. Then lastly, what's the turning point? It's both your value of the axis of symmetry, which is the inverse of the p value, and the maximum or the minimum value, which is the q value as it is from the form. Okay, guys, are we clear? Can I move on from this window and go on to the next window? Do we understand this? Okay, and of course, if a is less than 0, which one are we talking about? Maximum or minimum? If the minute a is less than 0, what does that mean? Concave down. The graph faces downwards. Concave down has a minimum turning point. Minimum. So we're at the bottom there, right? Okay. A less than 0. No, we're at the top there, sorry. Okay. Does it have a minimum turning point? Could it have a minimum if a less than 0? Hey, guys, is these notes correct? A less than 0. Is it a minimum? Do the notes need fixing? Is it a minimum really? Is this true what they've written down here? Let's see if people understand. This thing is, what is this thing saying? It says if a is less than 0, the graph faces downwards. That's true, that the graph does face downward. Concave down, that's true. But has a minimum turning point? Is that true? That it has a minimum turning point? Guys, is this a minimum? A is less than 0. I agree, concave down is 100% correct. No doubt, concave down. But is this the minimum? Are these notes correct? You will know people that know their stuff and don't. Minimum. Thank you, Samantha. Samantha is saying no, can't be. I agree with you, Samantha. This is nonsense, this one. Okay. Okay. Yes, maximum. We have a maximum turning point, please, guys, eh? Yeah, so whoever was compiling these notes, KZN, I blame you. If you're from KZN, yeah, you see, now imagine if I was gullible and I didn't know my stuff. Me, I was gonna say, yeah, it's minimum, guys, minimum, and then you guys get lost, and then you feel like, hey, this guy is teaching us, he's paraphining us, this man. Okay, so we have a what? Have a maximum, guys. This is a maximum. A less than 0, give maximum, give max. All right, we have a maximum value. Our y value is the maximum value, the q. Then if a is greater than 0, yes, the graph faces upwards. That's very true. Okay, when a is greater than 0, the graph faces upwards. It's concave up. But does it have a maximum turning point? These guys. Hey, give my paraffin. Hey, these people. Okay, so it doesn't have a maximum, but rather it has a what? A minimum. Okay, very careful here. Minimum. So if a is greater than 0, all right, we are very happy, smiling face, but we have a minimum, a minimum turning point here, because we know that our q value gives us a minimum value. So the minimum is equal to q, right? Yeah. So let's also take note of that. Okay. The concave what? Concave up. All right. Okay, we good. I'm sorry about that cough. Yeah. So I'm sure we are becoming experts in this thing. We're like, we see now. We see. Oh, so this thing is turning point. The inverse of the p gives us the equation of the axis of symmetry, which is also the x-coordinate of the turning point. There it is, negative p, x-coordinate of the turning point. The q value gives us the maximum or the minimum value, which is also the y-coordinate of the turning point. There it is. So the turning point is negative p. There it is, negative p, our x-coordinate of the axis of symmetry, and then q, which is the minimum or the maximum, depending on who a is. Is a less than 0, which would obviously mean that is the what? That is the maximum. And if it's a greater than 0, that would obviously mean that is the what? That is the minimum. Okay, moving right along. Let's check this guy. We can't hear. Yeah, you couldn't hear because for a moment there some puzzle came up. So I was just gonna repeat one more time. Let's just repeat this thing one more time. I was saying in the turning point form of the function, okay, we know that the axis of symmetry, the equation of the axis of symmetry is given by what? It's given by the inverse of the p value inside this bracket. In other words, if you take the x plus p, you equate it to 0, x is equal to negative p will be the equation of the axis of symmetry. Furthermore, this is also referred to the x-coordinate. The negative p is referred to the x-coordinate of the what? Of the turning point. Okay. Then, depending on whether a, in this case, is less than 0, the graph faces downwards, it is concave down, then we know that we have a what? Do we have a maximum or minimum when a is less than 0? We know that when a is less than 0, we have a top maximum. Okay. So that means our q value will give us that maximum value, right? Then when a is greater than 0, we have a what? We have a minimum. The corresponding y value, the q value, is the minimum value. Okay, the lowest point. Okay, I hope that makes sense. Then let's move right along. Domain and range. Hey, domain and range, range and domain. So once again, guys, domain for a parabola, if the parabola is an unrestricted, you see, unrestricted, no endpoints, just simply, how do you write the minimum? You just write minimum is equal to, then whatever the y value of the turning point is, you just write the minimum value is equal to, and you write that value. That's it. That's how you write the minimum. Okay. Yeah. So for instance, let's just say you had your coordinates of the turning point as being, let's just say, okay, let's just make an example. So if I came to you and I said, here's the equation of the parabola, you can see that this is the turning point for. Then I say to you, what is the equation of the axis of symmetry? Let's start there. The equation of the axis of symmetry. Okay, so obviously what you would do is you would take the expression inside the bracket, which is x plus 3. You would equate it to 0. of course, because that helps us then to be able to write down the equation of the x of symmetry. X is equal to, take the 3 over, x is equal to negative 3. Good job. Definitely. X is equal to negative 3. Very good. 1. Okay. So if I ask you what the equation of the x of symmetry is, you take the expression, equate to 0. There's the equation of the x of symmetry. Then, number 2, I then say to you, what is the, do we have a minimum or a maximum value for this function? Do we have a minimum or maximum? Do we have a min or max? And then I ask why. Do we have a minimum or maximum, and why? Okay, so Riatle Hile says minimum, Rotendo says maximum. Now that's very interesting. That means, what do we do when we want to determine whether we have a minimum or maximum? We go and look at the form of the function. We look at the what? The a value. Remember, we said that the form of the function is y is equal to a, and our a value will tell us whether we have a minimum or a maximum. So we look at this. What is a? A is equal to 2. What does that mean? It means a is greater than 0. What does that mean, guys? If a is greater than 0, what type of function do we have? We have a positive, which means we are smiling like this, which means we have a what? A bottom guy. What is that bottom turning point? It is the minimum. So I'm going to say we have a minimum. What's the reason? It's because a is greater than 0. Okay, please guys, let's be very careful when we do these things. So we have a minimum here. Then number 3, I ask you, what is the minimum value? Okay, and then in actual fact, I wouldn't say what is the minimum value. I said, do we have a maximum or a minimum, and why? So you would tell me, right, that we have a minimum, and you would say because a is greater than 0. Then I ask you, give me the value of the maximum or the minimum. Then, of course, having identified that it is the minimum, I would hope that you would say minimum value. Okay, Rotendo said it very well. Minimum value, remember we said it is q as it is. What is the q value? It is positive 4. So the minimum value is equal to 4, guys. It's as simple as that. Then the last question I ask you, give me the coordinates of the turning point. Okay, that would be the last question I would ask you. Let me just wait for you in the comment section to populate the coordinates of the turning point with the right answer. I'm waiting for you. I know you guys will give me the right answer. The turning point, guys, of the turning point. What would be the turning point? Bruntendo. Oh man, KK, I'm so sorry about that. Condolences to you. My goodness. Well, I'm glad you're back as well. I'm very sorry about that. Condolences, dear. Condolences. God's blessing and peace be upon you, your family, and and just be given the grace and the strength to be able to allow the good memories to flood your heart and your mind and your soul, and hopefully all the good memories and all the good times you guys had would be fuel and reason for you to just continue on and press on. I'm sure your brother would have probably wished so much the best of things for you in life. Hopefully that would be fuel to sort of like help you press on. And those memories, man, good memories that you had. It's good to mourn when you have to. But thanks for sharing that, and I'm really sorry. Condolences to you and your family. Okay, I see you guys did flood the comment section there with the answer. So very good. -3 and 4, you guys have it covered. Very good. -3 and 4 are definitely the coordinates of the turning point. There and there. Good job. You guys are good. Where did we get the x from? There. Okay, the minute we could identify the equation of the x of symmetry, taking the expression, equating it to 0, got the x coordinate of the turning point. There it is. This is the equation of the x of symmetry, but it also helps us to locate the x coordinate of the turning point. Then minimum value, because we know minimum value is 4. There it is, guys. You see, the y coordinate of the turning point is the minimum value, which is 4. So there it is. The coordinates are -3 and 4. Good job. You see how efficient and good and precise y'all are. You guys are. Look at it. Okay, so that means this window and this window, you have sorted the concept for this window and this window. You guys are like spot on. You guys should give yourselves a round of applause. Like, I mean, you guys are phenomenal. My goodness. Gosh. Okay, let's move on to the next window. Domain. So if we look at this window, what is the domain? Domain is the possible x values where the function exists. And we said when we look at domain, we are looking at the function from left to right. Very important. Whenever you look at domain, you're looking at from left to right. So if the function is an unrestricted function, okay, unrestricted, guys. Unrestricted functions are always functions that have no beginning, have no end, from left to right. So if you're looking from left to right, you can see that there's no beginning and no end. So if I say domain for a function like this, it's like x is an element of real numbers. Okay. Or if you don't want to write it like that, you can always say x is an element, because this means the same thing. X is an element of -infinity to +infinity, one and the same thing. So if you do that, that's fine. Okay, so that's why you see this here in the notes. They're saying the domain is x is an element of real numbers. But this only applies if the function is unrestricted. No restriction. Unrestricted. No restriction. Okay, let's move on to the next thing. Range. The notes there are a bit cockeye, okay, because the sad thing is that there's no equal sign there, which is something that should be there. Okay, I just want to add that the phenomena, guys, of shaded and open dot is a phenomenon now that is just significantly finding its way in exam papers. All right, because this is integrating grade 10 topic and grade 12 together. So grade 10, that's where you guys learned about the advent of the open and shaded dot, shaded or shaded, call it what you want. Imagine if I was to draw this parabola, but then I would restrict it, you know, in this sense, in this way. Then it means if I say open, open, let's just say it said open, open, okay? Right, it would be imperative for me to know what the corresponding x values are. So let's say they said it was a -3 here, and let's just say for argument's sake that was 4. Okay, and then they say to you, write down the domain of this function. Guys, x an element of r or x an element of -infinity to +infinity, open brackets, won't help here because we are restricting this graph from a certain point to a certain point. So open, open obviously means open, open, but then of course we'd say from -3 to what? To 4. Do you see that? This is not a coordinate. This is us writing the domain in interval notation. X is an element from -3 to +4. And because we have open-ended, the endpoints are basically open dots, we obviously then put open brackets at either end. If it was shaded open, of course we would say square bracket, open. If it was shaded, shaded, then obviously we would say square bracket, square bracket. I hope we get the point. Just like I did with the straight line, and I had said that's how we write the domain if the straight line has visible endpoints. So this is something we need to be aware of, in as much as we know generally that writing the domain of a function, if the function is unrestricted, this is an unrestricted function, then of course we would say x is an element of real numbers, or we write it x is an element of -infinity to +infinity, open, open. But here we can't say x is an element of real numbers. Here we have endpoints. So from left to right, we can see this is kind of like where the function is existing in between these 2 points. Okay, So I hope that makes sense, guys. And that is just domain for an integration of inequalities in grade 10 with this domain concept as well in the mix. Then what about range, guys? Range, possible y values where the function exists. So obviously here with range, guys, we know as long as we know what the minimum value is, if we have the y value of the turning point, then it's easy to write down the range. We know that if a is greater than 0, as you can see here, a is greater than 0, then that simply means y is greater than or equal to whatever the y coordinate of the turning point is. Why do we say y is greater? Remember, this greater means y is above. The function exists above the line or the minimum, which is 2. Okay, but it also exists on that minimum value. Does that make sense, guys? Okay, so if a is greater than 0, we can simply say y is greater than or equal to 2. Or if you want to write it in interval notation, you can always say from q to positive infinity. You can see the q is included to what? To positive infinity. Remember, guys, that this q simply represents what? My minimum value. So if I know my minimum value, then it's y is greater than or equal to q. I can write in inequality form, or I can say y is an element of square brackets from q to what? To positive infinity. From the bottom to the top. From q to the number. So obviously this q value will be a negative value. Okay, so please, guys, just take note of that. Okay, this is just a variable, of course. It could be a negative number, it could be a positive number, it could be whatever it is, but you can see in this situation it would definitely have to be a negative number. Okay, so I hope that makes sense to you. Okay, but if we have a parabola and let's just say, for argument's sake, that a is less than 0, in other words, it says looking down, concave down, then of course y will be less than or equal to the maximum value. In other words, the function will be located, this less than means below the maximum. Below the maximum. Function exists below the maximum. Okay, now we could write it as y is an element of, open brackets, from negative infinity to what? To q, square brackets. This is one of two ways. Writing it in interval notation if you want, or writing it in inequality form. You decide. You decide the most appropriate one, the one that is appealing to you. Okay, but guys, really now, in functions, writing domain and range doesn't matter for which function. It should come easy. We should be experts now. By now we should be good experts. Okay, I just want to check if everyone is with me when it comes to domain and range of a function. Are we clear? Are we good? The fact that if it's an unrestricted function, domain is simply x as an element of real numbers. All right, but guys, the minute we have a restriction from left to right, then of course, guys, we need to consider, is it open bracket, open bracket. If it was shaded, let's just say it was a straight line like this. Forgive me for my yeah, man, you know what I mean, man. Shaded, then of course, we consider this thing x an element, then we say square brackets from -3 to what? To +5. We squareize the bracket because we see it's shaded both. If it's shaded open, then we know most. Shaded means square and open means open bracket, you see? So we always just make sure we align using our things to resonate with what we mean. Otherwise, it all becomes weird. So hopefully we understand the whole domain thing. For unrestricted, domain is as standard as the nodes, but then the minute we have these open, shaded, open, we must align ourselves accordingly. Look at the endpoints and write the domain accordingly. For range, range is straightforward because the range, if a is greater than 0, we know we're starting from the bottom to the top. From the bottom to the top, that means from q to what? To infinity. Okay, or we can say y is greater than or equal to whatever this minimum value is. It makes sense that we are saying it's above, the function is above or equal to whatever the minimum value is. Makes sense, this thing. One, either or, you decide which way you want to write, interval or inequality. If a is less than 0, it means obviously the function exists there on the maximum and below. Or we can write in interval notation from negative infinity to what? To u. Because please guys, we always start from the bottom to the top. From bottom to top, we always write from negative, from the smallest to the biggest. If you ever guys write in interval notation, you must write from small to big. Do you know guys, you will be wrong if you were to say y is an element of, let's say you say from q to negative infinity. This becomes 100% wrong. 100% wrong. If you mix the order, you are wrong, guys. You are wrong. And someone may look at this and be like, but say, isn't this like nearly the same thing? No, it's wrong. If you write it like this, you are wrong. If you write it like this, you are 100% sweet. Love, guys. Love comes. You see? It's like love. If you've been waiting for love, you receive it here. You receive it. The arrow, you know. Yeah, you fall in love, maths takes care of you, buys you things, and yeah, so much love there, right? Hope you can feel it. You can feel the love. Can you feel the love tonight? Okay, so that's why there we add the equal, because the notes are conquering. Yeah, if a is greater than 0, if a is greater than 0, y is greater than or equal to q. If a is less than 0, y is less than or equal to q. Interesting. Yeah, if a less than 0, y is less than or equal to q. If a greater than 0, y greater than or equal to q. I wonder, you guys, which way do you best prefer? Can I just get an idea in the comment section? Do you prefer writing the range in interval notation like this? Or do you prefer writing the range in inequality form? Let's see, interval or inequality. INE for inequality or interval INT. Or is like, I prefer both. I do both. Look at that, eh? Look at that. I can see Riyadlehil is going to have a hard time choosing the husband or the wife or the husband, the partner in the future, because he's going to be, I love them both. Whoever those both will be. But yeah, man, either way, you chose. Okay, let's move on to this part now. Can we move to this window? Riyadlehil is like, yeah, I'm definitely going to have a hard time. Laughing your head off, I say. Okay, y is equal to ax squared plus bx plus c. Guys, that is not the turning point form. This is called the quadratic standard form. Remember, the turning point form is the turning point form. There I told you can just read the x coordinate of the turning point, the inverse of p, negative p, x coordinate of the turning point. Q as it is, whether positive, it's positive q. If it was negative, we write negative q, whatever that value is. The quadratic standard form, slightly different. Okay, I want us to talk a little bit about this quadratic standard form so that we can iron out all issues pertaining to it, and then yeah, you know, we can have peace and joy and happiness. So if we are to look at this quadratic standard form, I want to look at this, guys. This is very important to me that we look at. Y is equal to ax squared plus bx plus c. Who here loves factorization? Let's just check in my comment section. How many people love factorization? Factorization is the love of your life. Factorization is the love of your life, because I want to talk about this a, this b, and this c, and I want to talk about the relationship that exists, and then we can look at other aspects of it. So Rutendo loves factorization. Guys, I hope you all love factorization, because the application of factorization you know, just generally algebra is very key in your paper 1. Okay, and never must you be as good and as well equipped in doing it than, you know, when you have to do paper 1. So if you look at y is equal to ax squared plus bx plus c, guys, let us just for a moment know that we all know now, by now, a greater than 0, a less than 0. All of us here know what is going on or what things are about, okay, where a is concerned. C. What is C, guys? Do you know what the C speaks to? Can someone tell me? In the function, what does the C speak to? Thank you, Samantha. C is the y-intercept, where our graph cuts, overlaps, crosses the y-axis. Okay, yeah. So we need to be able to know when to write our y-intercept as coordinates and when to write the y-intercept as a y-intercept. Because if you let x be 0, remember, it will eliminate this, becomes 0. It will eliminate all of that, becomes 0. And you are just left with the c value, which is the y-intercept. So that's why we call c the y-intercept. So our y-intercept can either be positive or negative. Okay, that means the graph will either cut, your parabola can either cut y where the y values are positive, or you can cut y where the y values are negative. Okay. Now I wanna help us to check something out very quickly using factorization. Let's just for a moment look at this. Here, can we all agree what is the value of a? Let's see in the comment section. A is equal to what, guys? Thank you, Retendo. What about B and C? B is equal to what? Thank you, Samantha. Thank you, Retendo. B is equal to 2. And then C, of course, guys, just taking it one step at a time. Thank you, Samantha. Thank you, Retendo. Thank you. C, thank you, guys. C is equal to 1. Now, what you note here is that A is greater than 0, B is greater than 0, and C is also greater than 0. In other words, all of our parameters, A, B, and C, are what? Are positive. Okay? I want you to note that. I want you to note that. Okay? I really want you to note that. And if that is the case, guys, when you factorize this, you are bound to get that, and therefore, because you have the same x value, it means x is equal to -1. Okay, yeah, but this is obviously because in this situation, this is also what we call a perfect square trinomial, which makes sense. All right, now I want to then also furthermore do this and see what happens when we sketch this kind of function. Let us come here, guys. Do you see what this is saying? Remember when we had the turning point form, our axis of symmetry was simply the inverse of the p-value. Inside the bracket, we take the expression equated to 0, we get the x-coordinate of the turning point, which is also the equation of the axis of symmetry when x is the subject. How do we get the axis of symmetry for this particular function? We are told that axis of symmetry is equal to x is equal to minus b over 2a. Okay, mind you, this form of the function is only received when we want to find the equation of the function where the function has two x-intercepts and maybe possibly one other point. We can always find the equation of this function in this form if we actually move from the point of first substituting the x-intercepts of the particular function, and then after that substituting the one other point so that we can find the a value, and then after finding the a value we distribute and we are able to write the equation of the function, the straight line function, in this form. Okay, but it obviously begins here when we are asked to write the what? To actually find the equation of the function when we are given two x-intercepts and one other point. So there are two types of questions, or maybe even more, but the two types of questions we can get where it comes to finding the equation of the function is either you get given two x-intercepts and one other point, you use this form to find the equation of the function, where you can get the specific a values, the specific b value, and the specific c value, and then have the equation. Or you can get given the function in the form where we have a turning point and one other point. If you have a turning point, it means you can immediately substitute the p and the q value, and then of course you can use the one other point, substitute it into y and to x, and then solve for a, so that you can then return back that a value and then get the equation of the function in this form. So please guys, we use this to find the equation of the function when we are given a turning point and one other point, and we can use this form of the function, this one, to get the equation of the function when given two x-intercepts and one other point. Obviously examples will follow, but I mean guys, this is just something that when we look at this, these windows for concepts for a parabola, it's so nice when we look at these and we are like able to reconcile the knowledge we have gained, and we can actually remind ourselves and recap very quickly. Oh, okay, I remember that, oh, to do this when the parabola is concerned is good. Now imagine when you have this information, you know it very well. When you are answering any exam paper, any past exam paper, what happens, guys? It is easier to be able to do what? To actually answer the question. It is also a confidence booster for you to be able to look at a question and be like, you know what, I know the concepts that need to be unraveled and unpacked and also applied here so that I can be able to do what? To solve the problem. So let us make sure that our conceptual understanding of mathematical concepts is solid, so that we can ensure that when we do questions, we have that important knowledge. People perish because they lack knowledge. That's why people fail, or people are unable to attain unto the marks that they need to. You can practice past papers till you are blue in the face, but if you don't understand the concept first and you understand it well, it becomes difficult. You can even look at the question paper and do the questions, but you may not necessarily be able to navigate your way through to the solution. But I hope you get this point that I'm trying to make here. Okay, yeah, I pretty much summed that up. Now I want to come back here. Remember, what did I want here? I wanted to actually get the coordinates of the turning point. So let's just get the x coordinate first. X is equal to minus b over 2a. What's negative? The b. Oh, there's the b. So I substitute the b, the 2, and the a. The a there is 1. The numerator means negative 2. 2 times 1 in the denominator is positive 2. What's a negative divided by positive? It's negative, and then obviously 2 divided by 2 is negative 1. So x is equal to negative 1. Now you should see that the x-intercept of the graph coincides with the x-coordinate of the turning point. The x-intercept of the function coincides. What do we mean by coincide? It is the same as the x-intercept is the same as the x-coordinate of the turning point. It makes sense. Why? Because I have a perfect square trinomial. A perfect square trinomial by nature will have a x-intercept that is the same as the turning point. So where we turn, that's the only place where there is a intercept with the x-axis and no other place, right? Now obviously the y-coordinate, if I want the y-coordinate of that turning point, I'm going to take this x, go and substitute it in the original. X squared plus 2x plus 1, took the negative 1, in brackets I substitute, I get 1 plus 2 into negative 1 plus 1, which means 1 plus 1, that is 2. Then obviously that minus 2, positive 2 times negative 1 is negative 2. So 2 minus 2 gives me 0. So my coordinates of the turning point is negative 1 and 0. Do you see that, guys? So now if I sketch the function, by the way, let's get the y-intercept as well, where we let what? We let x be equal to 0. And you'll remember very well, I said the y-intercept is the c value, but I'm just gonna routinely make sure I confirm that. So y is equal to 1. So the coordinates are 0 and 1. So 0 and 1, guys, are here specifically. The turning point is negative 1 and 0. Okay, which is there. And all I do is okay, do you see that? Then I'm just going to look if I can't get another corresponding this y value when y is 1. X squared plus 2x, 1 minus 1 is 0. You get x is equal to 0 or x is equal to negative 2. So that means the negative 2 there. Negative 2 and 1. And there's the other point. At least I have 1 point this side, 1 point that side, and then the turning point. Now guys, this is just how I got to sketch the graph. Okay, yeah. So all I was just trying to show you by doing this was to show you that given that this is a perfect square trinomial, the x-coordinate or the x-intercept of the graph is the same thing as the turning point if the function is a perfect square trinomial, right? Yeah, where I was able to get to one x value. But of course, if it was not a perfect square trinomial, I would have gotten 2 x-intercepts and the graph would have cut the x-axis at 2 places. Okay, yes, and that is to also say that sometimes the situation warrants us to have a function where the graph does not have an x-intercept. There are times when the function does not even cut the x-intercept. Okay, but what is worthy to note here is that the function exists. If I was to ask you what is the range of the function, okay, can I just check that? Let's see. What is the range of the function, guys? Let's see in the comment section. Can I see if people can tell me what the range of the function is? The range, let's start with the range specifically. What would be the range of this function? The range before I send you guys all to sleep. What would be the range of this function, guys? This one. range in your function. Rotendo, I see. I guess Rotendo, is that your infinity there? Okay, I see what Rotendo's done there. And you say negative infinity to 1. Okay, is saying y is an element of R4 to infinity. I don't see. Okay, then Samantha is saying y is greater than or equal to negative 1. Be very careful, guys. Do we know what the minimum is here? The minimum value. Okay, remember this function is touching the x-axis. Everywhere on this line, y is equal to who? To 0. So what is the y value at this point? It is 0. Okay. Y is less than 0. No. Be very careful, really. Y is greater than or equal to 0. What does that mean? Y is above or equal to 0. Remember, the function is lying on the straight line. The y value is 0. Don't be fooled by the fact that this is the x value. Remember, this is the x value. Y is 0. I think most of you got fooled by this negative 1. But you omitted to actually check that, oh, the function is on the x-axis. Since it's on the x-axis, my y value on the x-axis is always 0. Okay, so that means if you are going to write down the range, y is greater than or equal to 0. Yeah, Rotendo. Y coordinate of the turning point is not negative 1. This is the x value. So range is the y value. Possible y values of the function exist. From the bottom to the top, where does the function exist? So the y value at this point is 0, okay? Because the point here is negative 1 and 0. These are the coordinates of the turning point. But the y value is 0. So we say y is greater than or equal to 0, or we could say what? Y is an element of 0 to infinity. Careful, eh? Okay. Hi guys, we need to get this, right? Hanyan. What is the range? What is the domain? What is the domain of this function? What is the domain of this function? Thank you, Samantha. X is an element of real numbers. The domain of this function is definitely x is an element of real numbers. Okay. Yeah. Nintendo, be very careful. I never said you should start with infinity. You see now you are really you are saying things that I never said. Okay. I did say to you that a range means the possible y values from the what? From the bottom. So where's your bottom here? It's 0 to the what? To the top. What's your top here? We're going on forever and ever, higher and higher, okay, infinitely. So that means from 0 to infinity. Yes, Rutan, I never said anything besides that. Okay, I said range is the possible y values from the bottom to the top. And I said, if you write the order of things incorrectly, you are going to get penalized. So you must write the range for always, guys. When you're talking about range, you're talking from the bottom to the top. Started from the bottom, now you're here. Started from the bottom, now you're here. When you started from the bottom, how long ago was that? Okay. Nintendo, do you still remember yourself when you were still in high school and you were in grade 10 And remember how you looked like. Do you sometimes look at your high school pictures and look at them and look at them and like you look at yourself now and you look at your profile picture when you were in high school, maybe grade 10, grade 8, and you look at those pictures and you compare them to now. Okay, exactly. And I'm sure that laugh, that emoji of a laughter is an indication that indeed you started from the bottom with your image, now you're here. So please guys, whenever you're talking about range, you're starting from the bottom to the top. You are at the top now, but even now as you look at yourself, you think you are there at the top. But I'm sure in the next few years, again, I don't know, when you have reached another level, you'll be like, you'll be laughing at these pictures. You see, that's the funny thing about life. So from the bottom to the top, if we're talking about range. Then with domain, from the left to the right. Please, guys. Range, from the bottom to the top. Domain, from the left to the right. Why do we say from the left to the right with domain? Because your smallest values, your smallest are on the left, your biggest are on the right. Why do we say from the bottom to the top with range? It's because your smallest values are at the bottom and your biggest are at the top. I know, Samantha, I confused you. I that's why I did it. Okay, I wrote the numbers here that are on the x-axis. Okay, and of course you knew, as I had spoken to you, because jonga Samantha, when I was writing here the turning point, I said x is equal to -1, right? That is the x coordinate. You yourself should know this is the x coordinate of the turning point. But then the minute I say what is the range of the function, really and truly, your mind should have switched off from there and switched on to another. You see, I even went on and I substituted the -1 into the original equation of the function, got the y value, and I told you that the coordinates of the turning point are -1 and 0. This here is the y value of the turning point. But no one really took that seriously when I sketched the function. This is the x-axis. This is the line y is equal to 0. So the y coordinate is 0. Okay. If it was concave down, we were going to start with -infinity, Kaiten. If it was concave down, if you're going to write your answer in interval notation, you are going to say from -infinity to the maximum. So be careful, -infinity, to the maximum. All right. Yeah. This is me simply going through conceptual knowledge and understanding. So hopefully we are good now with these parabola concepts that we've covered so far. Okay, then look at grade 12. Parabola. Y is equal to ax squared, right? The inverse of a parabola, guys, the inverse is not a function. Hopefully we understand this. Okay, why are we saying the inverse is not a function of a parabola? If we have a parabola y is equal to ax squared, and we are saying the inverse is not a function, why are we saying the inverse is not a function? Okay, remember when we write the equation, we first swap the x and the y. So it becomes x is equal to ay squared. Then we make y the subject of the formula. We divide both sides by a, we take the square root, and then when we take the square root, we write plus minus. Okay, the plus means above the x-axis. The minus means below the x-axis. This is very important. The plus means above. The minus means below. Hey. Hi. You restrict the domain of y is equal to ax squared so that the inverse becomes a function. We know that the inverse is not a function. Okay, meaning both the positive and the negative, all right, of that expression. It is not a function. So what we then do is we restrict the domain, okay, of y is equal to ax squared, meaning the original function, so that the inverse can then become a function. Okay, so that's very important. Yeah, and our restrictions can go in one of two ways. We can either restrict the original function so that we have x is greater than or equal to 0. Okay, and I'm just gonna look at that. Or we can say x is less than or equal to 0. Hi guys, I just wanna show what we mean by. Okay, so let's say this is the function y is equal to x squared, right? The inverse, guys, this is the inverse, this one, which is x, it's y is equal to a over, is it a over x or x over a? Okay, let's just do this. What we do, we swap, then after swapping, we make y the subject. Okay, so like I said, this positive part represents this part of the function above the x-axis. This negative part represents the part below the x-axis. But then this entire function, this entire graph is not a function. Why? Because, guys, it does not pass what we call the vertical line test. You see, it cuts at two places on our function. And if it does that, then you say it's not a function, it's a relation. Okay, one x value, many y values. Okay, so we say it's 1 is too many, and the 1 is too many. One x value. Yeah, you see, it's a problem, that thing. One x value, but many y values. Now, so for instance, I could have x is equal to, here in this plot, -1, but there will be many y values. Okay, the y value here will be a certain number, and the y value here will be another number. So this is what we call a one-to-many, and a one-to-many is not a function. Okay, we call this a relation. Okay, so that's why we say the inverse of y is equal to x squared is not a function, meaning this entire thing is not a function. So what we do in order to actually represent this as being a function, we go first and we restrict, for instance, this original function y is equal to x squared. So we are going to say y is equal to x squared is going to be represented where x is greater than or equal to 0. Now think about it. If I'm saying x is greater than or equal to 0, it means I'm only going to see this part. Alright? Yeah, only that part. Then that means its inverse is going to be that part. Okay, because it is going to be symmetrical along the line y is equal to x, if that makes sense. So you say this here is going to be the inverse of the function. Okay, so that would be the y is equal to the square root of x, but it would be not plus minus, it would be just the positive part. This is also where x is greater than or equal to 0. So if y is equal to x squared is greater than or equal to 0, this is the function. Okay, And then its inverse is basically y is equal to the square root of x, where x is also what? Greater than or equal to 0. That is its function. That is the inverse of the function. So we call this would qualify as an inverse. Why do we say it's an inverse function? It's an inverse function because it is 1:1. We know that a 1:1, for every x value, there's one unique y value. For every x value, there's one unique y value. A 1:1 is called a function. It is not a relation. Okay, so this is an inverse function. It is a function. Y is equal to the square root of x, where x is greater than or equal to 0, is a function. Okay, so these are important things. You restrict the original function, you restrict its domain. So the domain is no longer x is an element of real numbers, but you restrict the domain so that it's x is greater than or equal. In other words, x is greater than or equal to 0. It's equal to 0, but also greater than 0. So then when you do that, it means that the inverse of the function is you are going to take the subject, the x and the y, swap it, right? As you would have done here. And then after that, you take the square root on both sides. But because the function has been restricted, the original, it means even the inverse will be restricted according to the same restriction. And therefore, the inverse of the function would be that. Okay? Yeah. Let's say we had restricted the function, the original, such that, say y is equal to x squared, where x is less than or equal to 0. What is less than or equal to 0, guys? It means that the function is less than 0, but also equal. We include the 0, and we also say that it's less than 0. So what does that mean? It means that the inverse of the function will be y is equal to the square root of x. Which one? The negative square root of x, where x is also what? So in this case, it's not less than or equal to 0, but it's greater than or equal to 0. Yeah. So what you're going to see is that you are going to see that this one becomes this. Yeah. It's like this arm. It is basically that one. So this, the inverse would be that, and it would be symmetrical along the line y is equal to x. It's always nice to actually ensure that the line of symmetry is sketched. Okay, the line of symmetry is sketched so that you can see the function, the original, with its inverse. Okay, which is f inverse of x is equal to where x is greater than or equal to 0. That would be the inverse of the function. Okay, guys, I hope at least, man. Okay, I think for now I'm going to hold it right there. Oh sham, man. Oh sham. Pearl, are you pearled up? Miss Kekan? I think like we after 12 and 17 minutes past 12. I think I'm gonna hold it right there. I think for today. Alright. I'm eager to take you through to the others. Okay. But yeah, I think for today we can definitely hold it right there. Okay. So I hope we see this thing that if the inverse generally is not a function, but if we restrict the domain of the original, then we can ensure that the inverse is a function. Okay, and the two ways that we can restrict it, we can either restrict it by saying x is greater than or equal to 0, or we can say x is less than or equal to 0. Okay, which is very important. Very, very important. Very, very important. Yeah. And then of course, I think whenever we look at the... Oh, you like to try the questions? Oh, you like to try the questions? Yeah. Okay. You can... yeah. You can definitely see the questions. This is... the first one. The sketch alongside shows the graph of f of x is equal to negative into x minus 2 the whole thing squared plus 9. G of x is equal to b to the power x, where b is a constant. D is a turning point of f and a point of intersection of f. So D is a turning point of f, and it is also a what? And a point of intersection of f and g. So it's two things. Then we are told that B is the y-intercept, there it is, and A and C the x-intercept, A and C. Then they're saying determine the length of AC. AC. So in order to determine the length of AC, this is a former question. It's a level 2 question. Okay. So that means there's procedure that is needed. It's a procedural question, not a knowledge question. We need some knowledge, of course. And that is, if we want the length of AC, we need the coordinates of A and C. And in order to get the coordinates of A and C, what are A and C? You see, that's the way we need to think. They're saying determine the length of AC. So we need to find out where is A and C. A and C are on the graph, where located on the x-axis. We call that point A and C the x-intercept. What is the x-intercept? On the x-axis, we know that y is 0. So if we want to find the x-intercepts, we let what? Y be 0. Where? Of the function. Which function? The function of f, which is the parabola function. There it is. We have the turning point form of the function. So if we want the x-intercept, we let what? We let y be 0. So f of x needs to be 0. Then we solve this equation and we see what the x values are. You see, we start there. We start there, guys. We just start there. And I'm sure AC we would be able to get. Once we are able to get the coordinates, right? Those who are familiar with analytical geometry will want to use distance formula. Those who know the concept around a horizontal line will use the x-coordinate on the right minus the x-coordinate on the left to get the x-coordinate, the distance of AC. Because this AC is lying on a horizontal line. And if we have a horizontal line, we can use x right, meaning the x of C, minus the x of left of A, which is the x on the left. Then we can subtract those two and get the distance of AC. Okay, so is there anyone who has, maybe I can just hang on tight a little bit here in this live session. You can do question 1 and see if people are able to get there. So let me give people a chance. Please, guys, can you do this? I'm sure you guys can. You have the time. Yeah. Very nice question, by the way. Very nice. of course, if the question says 4 marks, what you want to do is to spend less than 4 minutes answering that question. Okay, because if you are able to spend less and less time per question, especially with complex questions, you can spend less and less time. It is very helpful for yourself so that you can get sufficient time to go back, retrace your steps, and see if there's any inaccuracies, and you can check and double check what you've done. But failing to finish questions timelessly can actually put you at a disadvantage as well. Thanks guys for the follow, and thanks for those who joined in. So AC, anyone who's been able to get to first find the coordinates of A and C, and then now they have found the distance? Anyone? Could it be Riatlehil, and that's why she's liking the live at the moment? And thank you so much for liking the live as well. Then 1.1.2 as well should be sweet to do. It's also a level 2 question. And when they want b, the value of b, that means they want the base of that particular function g of x. G of x is equal to b to the power x. So they want the base variable. And so you need a point that lies on the line or the function g of x. And currently, as things stand, you don't have a given point, but because you know D is the point of intersection of both functions, but more importantly, it is the turning point of the parabola function. If you look at the equation of the function, f of x is equal to negative into x minus 2 the whole thing squared plus 9, you can read the coordinates of the turning point, so you can get D, then substitute the points into the given function g of x, and then solve for b, and as a result know what the value of b is, which can then help you know how to write the equation of g of x. But you want b, that's all, so you get it by substituting point D, which you get from the equation of f of x, because the x coordinate of the turning point, we did say how you get it from the turning point form function, and the y coordinate of the turning point, we did go through how we get the y coordinate as well. And then that can help us to substitute and solve for b. Nice, straightforward. Okay, 1.1.3, determine the value of x for which g of x is greater than or equal to 9. Questions that might seem difficult, but they're really not. If you look at g of x greater than or equal to 9, you know that 9 coincides with the y coordinate of the turning point of the parabola. So a horizontal line drawn through D would represent the line which is y is equal to 9. And what they want is you to determine the value of x for which g of x is greater than or equal to 9. G of x tends to lean towards the right of the point of intersection D. So it's kind of like towards infinity from D all the way to basically the arrow G, which is sort of like somewhat a representation of the direction in which the function is going towards the right. So simply put, what you do is you'd substitute the value of 9 into any of the two functions. Oh, but anyways, you don't have to, because you know what the x-coordinate of D is. It's -2. So the value of x for which g of x is greater than or equal to 9 is actually x is greater than or equal to 2. Yeah, it is. X is greater than or equal to 2. Then 1.1.4, write down the equation of h if h of x is equal to f into x plus 2 minus 9. This is just simple substitution and expansion. H of x, new function you didn't know about. F into x plus 2, that just means where x is in the function f of x, you substitute x plus 2 inside the bracket, and then minus 9, you write the minus 9 outside the bracket after plus 9, so that it leads to basically the cancellation of those two. Yeah. Then 1.1.5, how can the domain of h, where's h? H is this new function. How can the domain of h be restricted so that inverse of h will be a function? Alright, so I think guys, I'm gonna pick up the corrections tomorrow, but yeah, these are also some of the other questions. So I'm gonna allow you guys to screenshot if you want, and I'll be happy tomorrow to actually go over these questions, right? But also I'll cover some of the concepts that are remaining for hyperbola and exponential, yeah, so that we can also have a blast of a time. I know that most of you, because you have been attending other sessions and you've been continuing on, please guys, don't feel like I saw someone saying it's like you guys feel like you betrayed me, you are attending other people's lives. That's great. I'm very happy when you do that, because yeah, I cannot avail myself all the time, but if you are able to attend other people's lives, so I saw Sam a lot attending a multitude of lives, and so in fact like religiously so, and I'm hoping, Sam, you are at a place now where you feel like supremely confident coming and approaching the final exams. You should totally massacre the paper and do very well and make yourself proud, and that goes for all of you. Thank you for joining, guys. I will definitely see you again to continue this beautiful section of work that we started on functions. I'm sure we'll make some real-time progress as we go along. Thank you. Have a great one, and lots of love to you guys, all of you. Cheerio. Bye-bye. You're welcome, Sam, Andrew. And thank you as well for joining. It's good seeing you again.